Saxon's Calculus, Lesson 57, is the fundamental theorem of integral calculus. And they waited to do these examples because they wanted to give you the title, Fundamental Theorem of Integral Calculus, when they didn't do that in the earlier lesson when we learned about the summation notation and that we're talking about the area under a curve. So let's just review that our area under a curve comes from integrating from A to B, whatever the equation is that they're giving us with the dx. So now that we have reminded ourselves about the formula, they go through some more explanation, tell you that they're now calling it Fundamental Theorem of Integral Calculus, talking about the area under. Okay, anyway, let's jump over to example 1. Find the area under the graph of f of x equals 4 sine of x, and it then says do this for between 0 and pi. So we are going to fill into our formula and integrate this. So where did the sine come from? Negative cosine. So this is basically negative 4 cosine of, I'll write the x at this point. So we've integrated it, but I have not done my from 0 to pi. So the upper one is always going to be the highest limit. The lower one is always going to be the low limit. When we do this, remember that you are subtracting the answer from the high one minus the answer from the low one. So negative 4 cosine of pi will subtract with, which is going to change it over to positive, 4 cosine of 0, that negative 4 when I minused it. Okay. So now, what is the cosine of pi? Well, pi is 180 degrees. So that's this line. Here's my triangle. I am traveling over. My hypotenuse will match, but I'm not traveling up to be stuck on the 180 line. So then the cosine of that, ca, adjacent over hypotenuse, is negative 1 over 1, so negative 1, times negative 4 makes 4. Plus, and then the 0 would be in this quadrant, so that's this line, so 1 is moving over, nothing up, 1 matches, again, cosine ca, adjacent over hypotenuse, that's 1, so 4 times 1 is 4, and then we add those together and we get 8, and because I'm talking about area, you always want something squared, and since they didn't give me a wording, we're going to use units squared. Now, example 2. Find the area under the graph of the function y equals x squared plus 2x plus 5 between 1 and 3. So we know we're going to integrate to find the area under it, and we're going to do that from 3 to 1, and then obviously the formula gets rewritten. All right, so now when we integrate, we are adding, so this is going to be x cubed, and then we know that the 1/3, the flipping of that goes in front, plus x, add 1 gets 2, so this is going to be 1/2 multiplying with 2. Okay, well that's a 1, so then that goes to x squared, plus, and then 5 gets the x that it didn't have. And now we have to plug in the 3 minusing the 1. Okay, so 3 plugged in will give me 3 times 3 is 9 times 3 is 27 divided by 3 goes back to 9 plus 3 squared 9 and 5 times 3 15, so 18, 33 if I've added that correctly, and I'm going to minus from that plugging in the 1. 1 cubed is 1, so that's a third. 1 squared is 1, and 5 times 1 is 6 plus a third, making that improper because I know I need to minus it. My options are to go ahead and borrow. I don't know. If I do that, that's larger numbers. I might want to try to borrow. Okay, so then this is going to be, give myself some space, 32 and 3/3, that's my 33, minus 6 and 1/3. 3/3 minus 1/3 is 2/3. 32 minus 6 26. That doesn't seem right. Oh, yep, okay. 26 and 2/3. And let's see, they have it as improper. So now 26 times 3, 78. So 9. So that's 80 over 3. Yes, okay. I should have written it where I could write beside it. 80 over 3 units squared, because again, we're dealing with area. Okay, their final one says example 3. These are starting to take more paper. Find the area under the graph of the function y equals, and since I know I'm going to integrate, I'm just going to go ahead and jump to that. The integration of 3e to the x plus 2 over x plus x squared between the values of 1 and 2. So 1 is my lowest, 2 is my highest. All right, so when we integrate, the e to the x remains e to the x. This is a 2 with a 1 over x, which means that came from natural log of x. And then plus add, so 1/3 x cubed. Now, plug in 2. So I'm going to put it over here. 3e squared plus 2 natural log of 2 plus 1/3 with 2 cubed minus this whole thing. I guess I should put them both in it. Minus plugging in the 1. So 3e plus 2 natural log of 1 plus 1/3, because 1 cubed is 1 and 1 times that remains the same. None of those are like terms that I can put together. So all of this should be on a calculator, although it doesn't look like they did. 3e squared, well, I can't do anything with that. Minus 3e, can't do anything with that. 2 natural log 2, 2 natural log 1, that's 2 different things. Oh, yes. Natural log of 1 is 1. Okay, so I do need to rewrite things. 3e squared minus 3e. Then the 2 natural log of 2, couldn't do anything with that. Then this became 2. I'm going to put it over here. And then this 2 times 2 is 4 times 2 is 8. So I'm adding 8/3. Wait 1 second. I'm pausing here because I just realized I wrote 2, but that's minus. So minus 2, and then minus the 1/3. Let's see what happens when we put all that together. Common denominator. Oops. -6 plus 8, 2. So 1/3. They have 7/3. Bet I have a sign dorked somewhere. Okay, but I do have the 3e squared minus 3e and the 2 natural log of 2. All right, let me pause and find my error. Yeah, okay. Natural log of 1 isn't 1, it's 0. 0 times 2 is gone. This shouldn't have existed. Oh, and then 8/3 minus 1/3 is 7/3. So there's our final plus 7/3 and units squared. There we go.